Hello, class. I want to update you on some of the things that we've been doing inside the classroom. And I wanted to look at speed and velocity. So, the highlight of this discussion is going to be over speed and velocity and how we use them. Both of these guys have equations, and those equations are very similar to one another. What's important about these two guys is that speed is a scalar quantity, and velocity is a vector. Okay, which means that speed does not really concern itself with direction at all. It's more concerned about the aspect of just simply having a magnitude. So things such as 25 miles per hour, that would be a speed. While the difference would be that velocity is a vector, so therefore it has direction to it. So in that case, I'm concerned about the direction that the object is going, such as 25 miles per hour northeast or south. So when I add the direction to it, it automatically makes that into a velocity instead of a speed. These two guys have equations in which speed equals distance divided by time, and velocity equals displacement over time. And with these two things, you understand as a result that that displacement within itself is a vector, and distance within itself is a scalar. So let's simply say speed equals d over t. And in this case, displacement, I put dsp over t for velocity. So those two things are very important to look at. So we have an equation. We have two equations, one equation for speed and another equation for velocity. And those are the two equations that you see on your screen. I'm going to exit out of this right here. The other part that's important is that of these two equations, it's important that you have the ability to manipulate the equation. So if I wanted to solve for something else. So for instance, what if I want to solve for time for this equation? Then if I want to do that, two things happen. Number one, I multiply each side by t. That'll cancel out these guys here. So I have t times s equals d. But I'm solving for t by itself, so I divide by s, divide by s. That'll cancel these two guys out. And I'm left with t equals distance over my speed. Now, the other thing that you notice for this being the equation and my original equation being velocity or speed equals distance divided by time, the only thing that happened is that these two variables were switched. So anytime you have three variables in which something equals something over another thing, if you take that bottom or the denominator and switch it with that thing that you're solving for, then you can find the alternate for it. So for the displacement equation, to solve for time, I will go time equals displacement over velocity. So that's the same thing. So as a result, I don't really have to do much to solve for that. To figure out displacement, I multiply each side by v if I want to do that, and I'll cancel that out. So that means that displacement equals velocities times time, and that'll be the same thing over here. So I multiply each side by t. This will cancel out. That means the distance equals speed times time. Okay. So that aspect is very important. When looking at this, it's also important to think about your units and how you're going to use your units and what units are important. The first thing is that if we have distance or displacement, both of those guys, as far as the major units, they're taken in units of meters or some type of distance. In our case, the metric system is kind of more the preference that we'll use or most of our examples. However, it doesn't mean that that's the only measurement. We still use miles and inches and centimeters and things of that sort. Centimeters are still part of that. It just has that prefix of the metric system. The other thing is time. As we know, time, generally we use seconds. However, we could still use minutes, hours, days. So that conversion part is important that you know some basic stuff that you should know, such as 60 seconds equals 1 minute, okay? Or 60 minutes equal 1 hour. So sometimes you have to convert between those two things. And then finally, for speed or velocity, in which let's go look at speed first. The equation for speed is S equals D over T. So the units will be your distance, whatever your distance is. In this case, I'm going to put meters divided by seconds or meters per second. Velocity would be the same thing, in which it would be some type of distance over time for units. But also, what's important is that you have some type of direction that's there. So that NE means northeast. So let's go work out a couple of equations, a couple of problems. So let's say that you had Stickman and Stickman was about to run. There he goes. Story's not about him. And he ran. Now, a couple of things are important. I'm going to talk about two terms as I go through this problem. The first thing is we know that Stickman runs, and he runs, let's say, a total distance. This entire distance is 100 meters. And let's say hypothetically that in order for him to run this, it took him 12 seconds to do so. So someone can ask, well, what's his average speed? And that's a term that we're going to look at, average. And what average speed means is that it is the total time over total distance. So this guy can go faster or slower throughout this race. We're looking at simply how long did it take for him to finish the entire race and what was the total distance as he did it. So we're going to therefore get an average speed. So in this case, I'm going to go SAVG equals my total time. In this case, my total time is 12 seconds. It's actually distance divided by time. I have this backwards. So it's my total distance. Divided by my total time. So S equals my total distance, in this case is 100 meters, divided by 12 seconds. So when I do that, I have 100 divided by 12. And the answer for that is 8.333. So I'm going to round that off to 8.33. And my units, I remain the same. I keep them the same, meters per second. I always have a habit of putting my answer inside some type of bracket or square or circling it just so I can know, or like whoever's looking at my work can know that this is my answer. So two things that we look at. The first thing, this term, average speed. And average speed means like the sum of all distance divided by the total time for whatever that trip was. And then there's another word that's important that we will use later, known as an instantaneous speed. And what happened in an instantaneous speed that is the speed that you're moving like right now at that moment. So like for instance, if you had a police car and that police car had a radar gun on it because that policeman was determining how fast traffic was moving. That's my police officer with his radar gun. What that radar gun would do is that it would send a signal out and it would determine how fast someone else was going at that particular time. So in that case, I don't know what type of, say this is a motorcycle, I guess. At that case, I can determine like, okay, this guy is going 25 miles per hour. And that's the time, that's the speed that he's going right now. The police officer is not concerned about like how what his average speed is. He's concerned about how fast is he going right now on this particular road at this particular time. So he's getting an instant speed, better known as an instantaneous speed. Okay. So I wanted to look at those two things. I wanted to look at the equations. Those things were important. We have several equations to look at when we do this. So the first one was velocity equals displacement over time. And we can rearrange that to solve for time. Time equals displacement over velocity. And then finally, we can solve for, if we like, displacement. And that equals times velocity, or velocity times time. It does not matter. Same thing for speed. Speed equals distance divided by time. Time equals distance divided by speed. And then distance equals time times speed. So these are our main equations, and these are our guiding points for us as far as this is concerned. So if you have any questions about this, what's important that you understand is the average speed versus instantaneous speed, and how to calculate each of these guys and how to put them inside your calculator. So if you need help, let me know.